Good morning, 8th standard. The next chapter that we are going to start is chapter number 6, Squares and Square Roots, from your NCERT book. It's on page number 89 in your textbook. And before we start with the chapter, let's write down definitions. So before we do the questions, we should know what squares and square roots means. To begin with, let us write down what square is. The word square is used to represent exponent 2. So this is something you are aware of. If there is a number whose power is 2, we read it as square. So for example, if you have 7 raised to the power 2, it is written as 7 square. This is how you write down. 7 is written normally and 2 is written as a superscript. And how do we read it? It is read as 7 squared. So usually when we are speaking 7 squared, this D kind of dissolves. So we read it as 7 square. So this is how we are going to do it. So if there is exponent 2, we don't read it as 7 raised to the power 2, we read it as 7 square. So the answer that you obtain when you raise a number to power 2 means the answer that you obtain by solving the square of any number is called a square number. The answer obtained by raising the power 2 of any number is called a square number. That is, or for example, 7 raised to the power 2. So I have a number 7, I'm raising the power 2. So raising the power 2 means I'm writing down the square. This will be 7 into 7. This will be 49. Let's take one more example. Let's take 12. Raising power 2. So 12 into 12. The answer will be 144. The numbers which I obtained after squaring, these are square numbers. Therefore, 1 square. I'm starting with the natural numbers. So you're counting numbers. The first number is 1. If you write it square, it will be 1. Next is 2. Squaring 2, you will get 4. The next number is 3. Squaring 3, you will get 9. 3 into 3. Next number is 4. So if you write down the square of 4, 4 into 4 will be 16. These are square numbers. And these are also called perfect squares. Geometrically means with the reference to geometry. If we are talking about square numbers, what we have is square number represents area of a square. Why so? If I'm squaring a number, how does it represent area of a square? Consider 5 square. So 5 square will be 5 into 5, it is 25. And this 25 actually is area of a square with side equal to 5. So if there is a square whose side is 5 units, it could be any unit, centimeters, meters, kilometers, whatever, irrespective of the units. If there is a square whose side is 5, we calculate its area. Its area will be side square. So that will be 5 square, which means the answer will be 25. So 25 represents area of a square. So if m is a number, let us say we have a number m, it will be called a square number or a perfect square if we can find n such that m equals to n square. Now what does this mean? This means that if you have any number, let us say we have a number 36. For 36, m is 36. For 36, I can find a number 6 such that 36 equals to 6 square. So if there is any number, you have to find another number, and the relation between your given number and the number you have found is that the given number equals to square of the number that you have found. So for any number, if you are able to find n such that on squaring that number the answer is your number, then you can say that m is a perfect square. So if you have 11, can you think of a number whose square will be 11? No. There is no number whose square gives you the answer 11. So 11 is not a square number. Think about 225. Can you think of a number whose square will give you 225? Yes, 15. 15 square will give you 225. So 225 is a square number. Any number which was obtained by squaring some other number is called a square number. So if you have to check whether the given number is a square number or not, what you can do is you can think if it was obtained by squaring any other number. You will be learning some other methods also to check whether a number is a square number or not later in the chapter. The next thing we are going to discuss is properties of squares or square numbers. First property is the digit at ones place. So what we're going to observe here is the relation between the digit at ones place of a number and the digit at ones place in the square of that number. Ones place means the last digit. So let us write down a few numbers and see what happens when we calculate the square. And we are only going to observe the units place, the ones place, last digit. So I am starting with my natural numbers. If you want, you can look at table on page 90. Now let us see what happens when we square these numbers. On squaring, 1 square will be 1 into 1, 1. 2 square, it will be 2 into 2 equals to 4. 3 square will be 9. 4 square will be 16. 5 square will be 25. 6 square will be 36. 7 square will be 49. 8 square, it will be 64. 9 square will be 81. 10 square will be 100. So you can keep writing further, but the ones place will be these digits. So when I write 11, so I am actually having ones place equal to 1. If I write 12, then ones place is 2. I am not writing further. So you can observe from this table, from the first 10 natural numbers, because we are only looking at the ones places. So if you look at these numbers, the ones places are 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And after squaring, what happens? After squaring, if you observe the ones place, which digits do you see? In the square numbers, this is the list of square numbers. In the list of square numbers, which digits do you observe? We observe that a square number has following digits at ones place. The digits which we can see here, I have underlined. These are the digits that we have in this list at ones place. I have 1 in the square of 1 and in the square of 9. Then I have 4 in the square of 2 and in the square of 8. Then I have 5 which appears in the square of 5. Then I have 6, it appears in the square of 6. 9 appears when you square a number ending with 3, a number ending with 7. And 0 appears when you square a number which ends with 0. So this is what it means. If a number ends with 1 or with 9, on squaring, the answer will end with 1 for both. Square of 1, square of 9 ends with 1. Then square of 2 and square of 8 end with 4. Square of 2 ends with 4. Square of 8 also ends with 4. That means if a digit ends at 2, the answer of its square will end with 4. If a number ends with 9, its square will end with 4. The numbers 3 and 7, their square ends with 9. So if any number has 3 at the end or 7 at the end, on squaring the answer will end with 9. If a number ends with 5, on squaring its answer will have 5 at the end. Same for 6. If a number ends with 6, the square of that number will also end with 6. You can take examples and verify this property. So we have observed these results. This is very vague observation. We are going to write down point by point later on. A square number has following digit at ones place. So this is what I observed. I could see these digits. Which digits did not appear in the square list? These 2, 3, 7, 8. There is no square number which ends with 2, 3, 7 or 8. So based on this, let's write down what can we say about the digits at ones place in a number and the digits at ones place in the square of that number. First note is, if a number ends with 1 or 9, its square will end with 1. I have taken examples. 21 squared. 21 ends with 1. On squaring, the answer is 441. The square ends with 1. Second number is 29. It ends with 9. Its square 841. The answer ends with 1. The numbers had 1 and 9 at the end. Their squares have 1 at the end. Same way, if any number ends with 2 or with 8, the square will end with 4. So if you have a number whose last digit is 2 or a number whose last digit is 8, after squaring you can see that the answer ends with 4. The next property that we have is, if a number ends with 3 or 7, then the square of that number will end with 9. So I have taken two numbers, 23 and 17. This ends with 3, second number ends with 7. After squaring, the answer for both ends with 9. If a number ends with 5, the square will also end with 5. You can take any number which has 5 at the end. On squaring, the answer will also have 5 at the end. If a number ends with 6, its square will also end with 6. Take any number which has 6 at the ones place. So after squaring, this will also have 6 at ones place. So if a number ends with 6, its square will also end with 6. If a number ends with 0, then its square also ends with 0. Consider 10. 10 square is 100. 200. Its square is 40,000. But the number of zeros gets doubled. In 10, there is single zero. After squaring, how many zeros do you see? 2. Double zeros. 200 has 2 zeros. After squaring in the answer, how many zeros are there? 4. 2 zeros. After squaring, they double. 4 zeros. So from here we can note down a very important result, that a square number always has even number of zeros at the end, because on squaring the number of zeros is doubled. After doubling any number, the answer is even. So if there is 1 0, on doubling the answer will have 2 zeros. If a number has 2 zeros at the end, doubling, the answer of the square will have 4 zeros. If a number has 5 zeros at the end, on squaring, the answer will have 10 zeros at the end. So every time you square a number which ends with 0, the answer will have even number of zeros at the end. Then looking at the squares of even and odd numbers, you can also tell this. Square of any odd number is odd. I have taken 2 examples, 13 and 27 odd. Squaring, the answer is also odd. Square of even number is even. I have taken examples 14 and 26. Their squares are also even. You can take examples yourself as well to verify. Now the most important result that we have is, if any number ends with 2, 3, 7 or 8. So if a number ends with these digits or odd number of zeros, then what can we say about that number? That those numbers which are ending with any of these digits or which end with odd number of zeros, they can never be a perfect square. For example, I have taken a few numbers. 23, it ends with 3. It is not a perfect square. You cannot think of any number whose square gives the answer 23. 77, it ends with 7. It is not a perfect square. 98 ends with 8. This is also not a perfect square. 432 ends with 2. This is also not a perfect square. Consider a number ending with odd number of zeros. 1000. These are not perfect squares. These can never be perfect squares. Any number with 2 at the end, 3 at the end, 7 at the end, 8 at the end, or odd number of zeros at its end will never be perfect square. And as far as other digits are concerned or even number of zeros are concerned, the numbers may or may not be perfect squares, and that we will learn later in the chapter how to find out. So now we know if a number ends with 2, 3, 7, 8 or odd number of zeros, it is never a perfect square. What about the other digits? Other digits are 1, 4, 5, 6, 9 and the numbers which have even number of zeros at the end. What can you say about those numbers? Those numbers may or may not be perfect squares. How so? I have listed a few numbers. Numbers ending with 1, numbers ending with 4, numbers ending with 5, 6, 9 and even number of zeros. Now if you look at these numbers, this not perfect square. This perfect square, because you cannot find a number whose square will give answer 11, but for 441 you can find. It can be obtained by squaring 21. This is a perfect square. Both end with 1. One is a perfect square, the other one is not. Look at these numbers. This is not perfect square and this is, because 64 can be obtained by squaring 8 and 24 cannot be obtained by squaring any number. Can you think of a number whose square will give you 24? No. 25, it is a perfect square. It is equal to 5 square. This not perfect square, because there is no number whose square will give you 35. So now you can see, if numbers end with 1, 4, 5, 6, 9 or even numbers of zeros, they may be a perfect square, they may not be a perfect square. Same thing applies to these numbers. This is perfect square because it is 6 square. This not perfect square. 89 is not a perfect square. 49 is perfect square. This is obtained by squaring 7. 200 not perfect square. 40 is perfect square. It is obtained by squaring 20. So for 2, 3, 7, 8 and odd number of zeros, we are 100% sure if a number ends with 2, 3, 7, 8 or odd number of zeros, it will never be a perfect square. But if a number ends with these digits or even number of zeros, we need to do some work to find out, and we will be learning that later in the chapter.